We didn't find it.
We didn't find it.
It's just not here.
It's all made up.
Everything is made up.
So thanks for joining us for this part 2 of our LDS roadshow, road trip. You've already seen us go to Heathrow. We started in good old Brum, roughly around here. And then we went to Heathrow, which you saw in the first video. From there, we made our way over to Hurn in the video you're about to see. And just to give you some future insight into the plans, in future, we will be driving over to Canbourne, right on the tip of Cornwall. Then we will head back through the Midlands, through the north, all the way up to Leeming. And then finally, our last destination will be Lucas, right up in Scotland, before, of course, making it back home in this sort of satisfying figure of 8 around the UK. So, I hope you enjoy this instalment in Hurn.
Welcome to Hurn. Now, Hurn is actually somewhere, a little village near Bournemouth on the south coast, and Hurn, the actual location of the weather station, which you can look up because the exact coordinates and actually the national grid reference are in the large data set at the top, is in the middle of Bournemouth Airport, which is behind us. We can just see the radar tower turning around over there. So let's get the weather readings done. Let's start with this device, so let's hold it up. It's warmed up a little bit since Heathrow, and so this is reading is 24.7 degrees Celsius, which is good. We've also found the button that changes the units on here. So instead of meters per second, which, as you know, is the incorrect unit for wind speed on the large data set, it is now in knots, the correct unit. So that is reading as 2.0 knots. Of course, there was a qualitative conversion to Beaufort. What would you say? Light?
We'll have to look it up, but
light.
It seems light to me.
Light, and maybe nearly fresh, but light. Certainly not moderate or strong or anything. So we tried to look up how this works. Here is a Beaufort conversion with different descriptions to what are used in the large data set. So we know that there is the word light, and from what we can work out, this is anything all the way up to 10 knots, and it's recorded as light in our large data set. Then anything between 11 and 16 seems to be called moderate, which goes along with this. Anything between 17 and 21 seems to be called fresh, and there are occasional strong readings. We couldn't find anything more than strong in the large data set. Maybe we couldn't find it. But yeah, these are the words and the Beaufort conversions for the certain knots. So we found it quite interesting that we saw so few strong readings, and in fact nothing any higher unless we're mistaken. Particularly since these years were chosen because they were years with particularly interesting weather events, such as the Great Storm of the night of the 15th to 16th of October 1987, which passed through northern France and the Channel Islands. It doesn't seem particularly well represented in these Beaufort conversions. If you look carefully, there's something that would be categorized here. I think it was something like 61 knots in these locations as the maximum gust, which here would be a violent storm, of course. But in terms of the Beaufort words, yeah, there's nothing more that we can find higher than strong. Very good. What's next? So this has been on the table again. This is our rainfall collector. Now it seems now we've stopped. The rain has gone away. It's not raining anymore. And of course, this is how invalid our measurements are, really, because at the current moment in time, I'm not going to sit at this beautiful setting of the Bournemouth Aviation Museum for 24 hours collecting rain. Just to repeat how this works, there's a little funnel at the top. This takes in rain in this certain circle here, and that feeds into this measuring cylinder inside, and this is the actual dimensions it should be. As you know, the measurements for the rain are millimeters, and this is 0 millimeters. But again, that would be over a 24-hour period. I really hope it starts raining when we're actually in one of these places. Anyway, so that's that. So what else have we forgotten to do? Wind direction. Now, wind direction we can measure in the cardinal wind direction, which is the direction the wind is flowing from. and we're going to go over to the air sock in a second to see what that is.
So if you look very carefully in between the middle two trees there, you can actually see an orange windsock. Now, it's blowing directly away from us, which if I look in my compass here, I can see my compass is north is that way. So I think directly ahead of us looks to me like it's 50 degrees. Now, that's where the wind is going towards. That's where the wind is blowing towards. So we need to say the wind is coming from down below that, which is 230 degrees, and that is a southwesterly wind. So our conversion in cardinal wind direction will be southwest, and the degrees, I think, are 230. So I think we now have direction right. Now, Mr. Winfield needs to corroborate this with the flag. So Mr. Winfield down here, does it actually blow in the right direction, or does it not? If we hold it up on the end, amazingly well.
I do trust the windsock more than this.
Shall we trust the windsock?
But it's kind of blowing in this direction.
Well, we'll take it, whatever. And the other thing we thought we would mention up here is visibility. Now, we can see pretty far. I'm going to say we can see at least, that's got to be 300 meters away over there. And then, of course, buildings stop us seeing any further. So as a lower bound, our visibility is, I think, 30 decameters.
What have we forgotten, Mr. Drew?
We haven't done anything to do with humidity.
And we were advised humidity was quite hard to measure, I think.
So we're going to ignore it?
But that would be a percentage. I don't know why it's hard to measure, but
it's hard to measure.
We took that suggestion and we weren't bothered. So that's a shame, but there you go.
Daily sunshine hours we haven't done.
Yeah, but again, I'm not sitting in this beautiful museum for 24 hours to do that.
No.
Because it's just it's quite bright. Despite the cloud cover,
which we can do.
We can do now.
Would we like to move the camera?
Yeah. Go for a little tour around.
Looking at very different sort of sky as we go along, right? It's all a wide array of different things to see. What would you call the octas today?
Well, I'm going to take this camera.
Yep.
And I'm going to point out
that there is some blue.
That's blue.
Now the question is it an eighth blue of the entire celestial dome? Or is it only a very small amount of blue?
I think it's probably still a solid 8 octaday.
A solid 8 octaday. Well, while we're sitting in beautiful Hurn, we may as well, of course, do a question about Hurn. So hopefully the question itself is on the screen now. This is our large data set question about Hurn. It's question number 4 from 2019. And yeah, this is concerning data from May to October, of course, as it always does, in 2015. So by using information from the large data set, Joshua wishes to calculate the mean of the total daily rainfall for Hurn from May to October 2015. Use your knowledge of the large data set. Well, thankfully, I have knowledge of the large data set. Explain why Joshua needs to clean the data before calculating the mean. Now, he's doing data about the daily total rainfall. The problem with the rainfall measurement is that sometimes you get these data inputs, which are TR, standing for trace, which is, I believe, any data or any measurement that was less than 0.05 millimeters. So they just put TR in that case. Now, what we need to do, of course, we can't find the average of a bunch of numbers if there's a bunch of TRs in there. So we just round those all to 0. So we'll put on our answer here, cleaning the data means rounding all trace values to 0. And that will be our first mark. This is an 8-mark large data set question, by the way. Really shows how many marks can be obtained by knowing your stuff on this particular topic. Use linear interpolations. They've given us a big table here. They've given us some nice summary statistics, which are useful. Use linear interpolation to calculate an estimate for the upper quartile of the daily total rainfall. Now, if I add up all of my frequency numbers, and I'll just very quickly put those in the calculator, 121 plus 10 plus 24 plus 12 plus 17, we're going to get 184. So I think the upper quartile is going to be 3/4 of the way through that data. So let's times that by 0.75. A plane taking off over there, fantastic. We get 138. So we're looking for the 138th piece of data. Now I can see there's 121 pieces of data there, 10 there, so we're down 131 so far. So I think we're 7 into the third group, which has 24 data entries. So let's do 7 divided by 24, which is our fraction of how far we are into that group. Let's do that in a calculator, 7 divided by 24. Now the group itself has width of 4 from 1 to 5. So if we times that proportion, 7 over 24, times by 5, I'm sorry, no, it's times by 4, isn't it? Apologies, it's times by 4. Times by 4, we get 1.16, and then we add it to our initial value, which is 1, to get 2.16, or 2.17, I guess, rounded. So question C is calculate an estimate for the standard deviation. So we've been given the summary statistics. So let's just do the sum of fx squared all over n minus the sum of fx over n all squared. That will give us the variance. So then we just need to square root and we'll get the standard deviation. So let's do 7704.1875 divided by n, which was 184. We will take away 539.75 divided by 184 all squared, which gives us 33.2. That is the variance. So we'll square root the answer and we'll get the standard deviation of, I believe, hopefully 5.76 or 77 rounded should be fine. Okay, so some more marks here for working it, for knowing some things about the large data set. Say an assumption involved with using the class midpoints to do an estimate. Well, essentially the midpoints are just pretending all the data is that value. So from all this data between 0 and 0.5, we're pretending all of those values were 0.25. So this is going to be problematic if, well, I mean, that's the assumption we're making, and it's problematic if that's not the case. And that's what part B is getting at, or part 2, I should say. Using your knowledge, explain why this assumption doesn't hold. Well, in that first group between 0 and 0.5, we need to know that an awful lot of those 121 measurements were just 0. So when we're averaging, making the assumption that all of those measurements essentially are 0.25 is way above what they would be. There might be 100 zeros in there with a few 0.1s, a few 0.2s and so on. So the assumption here that all of that data can be written as 0.25 is a bold assumption. There are lots of zeros, so that's probably going to whack out our mean by a little bit. And then it says, state giving a reason whether we expect the average daily mean to actually be our the thing that we found, or higher or lower. Well, because there should be way more zeros that aren't accounting for anything, that's going to bring the average down, and I think we're going to expect that the average actual mean daily total will be less than any calculated value. I think that's our question done. So yeah, had a good time doing the Hurn question in Hurn.
So before we go, we actually thought we'd do one last thing here at Hurn, but it requires a little bit of a backstory first. That backstory is that in our rush to get out of Heathrow before the free parking runs out, we actually lost the question paper that I was working on there because there was a large gust of wind. And obviously gust of wind is important for our large data set, but this large gust of wind meant that the sheet of paper I was working on ended up underneath someone's car. So someone's going to return to the long stay car park at Heathrow with a large data set question about Heathrow underneath their car. What a present. Anyway, we thought we might continue this tradition and we might hide the question that Mr. Drew did earlier somewhere here at the lovely Bournemouth Aviation Museum, which you should definitely visit. So yeah, oh, he's found somewhere, I think. If you want Mr. Drew's question about Hurn, filmed in Hurn, come and get it. So we've come to Bournemouth Airport. We've paid £5 to pick up a passenger, and we thought we might actually be able to find the actual weather station. Could it be this?
I think it is this.
So just to explain what's going on here, if you type the exact coordinates for the weather station for the large data set gives you for Hurn, which it does give you in the top left of the spreadsheet, you get this coordinate here. So we figured it was going to be one of these buildings around the coordinate, just on the edge of car park 3. So we figured, okay, let's just pay to drive into car park 3. And then we could just walk to the edge of it and we could see whichever building it was nice and clearly. And then we got really, really confused because we couldn't find it, which you're about to see. And it turns out, if you then Google the list of weather station, Met Office weather stations according to their website, their coordinates are slightly more accurate, which you then type in and you get that the weather station is on the other side of the airport in this restricted area. So we were never going to see it and we were looking in completely the wrong place. And that was annoying.
So this says it's an electrical distribution centre, but it could have used to be this, or maybe it's something in here. I don't know, I mean, it doesn't really matter. So maybe it's that.
We didn't find it.
We didn't find it.
It's just not here.
It's all made up.
Everything is made up. Everything in that set data set is made up. Everything. There's no, we've been here and it's not here. What more do you want us to take from that?
Maybe it used to be
It's just
here.
not here.
And I'm really sorry if we came all this way and
We came
missed
all
it.
the way to Hurn and it doesn't exist anymore.